Hello children, today we are going to discuss chapter 4, that is structure of an atom. What are the charged particles? Atom has three types of subatomic particles. They are electron, proton and neutrons. Electrons are negatively charged. We can represent this by E minus. Protons are positively charged, P plus. Neutron is a neutral. So neutrons have no charge. The mass of the electron is 1 upon 2000 the mass of hydrogen atom, and the mass of proton is equals to the mass of hydrogen atom and is taken as unit 1. The mass of neutron is equals to the mass of a hydrogen atom and it is taken as unit 1. Now, discovery of the subatomic particles. In 1900, Sir J.J. Thompson discovered the presence of the negatively charged particles that are called electrons in the atom. In 1886, Goldstein discovered new radiations in the gas discharge tube and called them canal rays. These rays were positively charged, and this later led to the discovery of the positively charged particles that are called protons in the atom. And in 1932, Chadwick discovered the presence of particles having no charge in the atom, and that are known as neutrons. Now we will discuss about the structure of an atom. In the case of the structure of an atom, different scientists proposed different type of models. So first we will discuss the Thompson's model of an atom. According to the Thompson, an atom is similar to the Christmas pudding. And the pudding have positive charge. This is the pudding. The pudding, this red color part is a positive charge, and electrons having negative charge were like a plums. This blue color structure is compared as electrons. So he proposed that an atom consists of positively charged sphere and the electrons are embedded in it. The negative and positive charge are equal in magnitude. That's why this atom is totally electrically neutral. Rutherford's model of an atom, that is also known as Rutherford's alpha particle scattering experiment. Rutherford allowed beam on the fast moving alpha particles having positive charge to fall on the thin gold foil. He observed that most alpha particles passed straight throughout the gold foil, but some alpha particles were slightly deflected by a small angle, and very few particles appear to be rebound. So in this case, most particles are undeflected, they were moving straight. Some particles will deflect slightly with a very small angle, and some will bounce back. Now we will discuss what are the conclusions of the Rutherford's alpha particle scattering experiment. So most of the space inside an atom is empty. Why? Because most of alpha particles passed straight through the gold foil, and the atom had a small nucleus having positively charged. Why? Because some of the alpha particles having positive charge were slightly deflected by the small angles, and the size of nucleus is very small compared to the size of atom, because very few alpha particles appear to rebound, and most of positive charge and the mass of atom is because of the nucleus. So according to the Rutherford's model of an atom has positively charged nucleus as its center, and most of mass of atom is because of the nucleus. The electrons revolve around the nucleus in different orbits, and the size of nucleus is very small compared to the size of the atom. Now we will discuss about the drawbacks of the Rutherford's model of an atom. Any particle in a circular orbit would undergo acceleration, and during this acceleration, the charged particle would radiate its energy. So the revolving electrons would lose its energy and fall into the nucleus, and atom would be unstable. We know that but we know that very well that atom is totally stable. So what is the reason behind this? He didn't explain about this statement. This is the drawback of the Rutherford's model. Now we will discuss about Bohr's model of an atom. An atom has a positively charged nucleus as its center, and most of the mass of the atom is in its nucleus. The electrons revolve around the nucleus in the spherical orbits that are known as discrete orbits. These orbits are called shells or energy levels and are represented by the letter that is KLMN, or by number also, that are 1, 2, 3, 4. While revolving in the discrete orbit, electron will not radiate its energy. This is the structure of the Bohr's model. See, these all are the orbits, and we can represent these orbits via letters like KLMN or by a number that is 1, 2, 3, 4. And this is the positively charged part of the nucleus of atom, that is nucleus. Now, distribution of electron in different shells. How these electrons will distribute in different orbits. The distribution of electrons in the different shells was suggested by Bohr and Varese. The following are the rules filling electrons in the different shells. The maximum number of electrons in a shell is given by the formula that is 2n square, where n is the number of orbit as well as number of shell. In the case of first shell, that is K, 2n square, 2 into 1 square, that maximum number of electrons in the K orbit is 2. In the second shell, that is L, same, 2n square means 2 into 2 square. So the maximum electrons are 8. In the M shell, 2 into 3 square, that is maximum numbers are 18. And in N shell, maximum numbers are 32 and so on. If number of shells will increase, then number of maximum electrons will enter in the shell, that will also increase. Now, the maximum number of electrons that can be filled in the outermost orbit is 8. And electrons cannot be filled in a shell unless the inner shell are filled. So first inner shell will fill, then electrons will move towards the next orbit. Now, composition of atom of the first 18 elements. Name of elements and symbol, then atomic number, number of protons, number of neutrons, number of electrons, distribution of electrons and valency. Hydrogen, atomic number 1, electron 1. Helium 2, then electrons 2. Lithium 3, then 2, 1. This is the electronic configuration of the element. Beryllium 4, 2, 2. Boron 5, 2, 3. Carbon 6, 2, 4. Nitrogen 7, 2, 5. Oxygen 8, 2, 6. Fluorine 9, 2, 7. Neon 10, 2, 8. Sodium 11, 2, 8, 1. Magnesium 12, 2, 8, 2. Aluminium 13, 2, 8, 3. Silicon 14, 2, 8, 4. Phosphorus 15, 2, 8, 5. Sulfur 16, 2, 8, 6. And chlorine 17, 2, 8, 7. These all are the number of valencies. Means how many electrons element can lose as well as how many electrons can element gain. According to this, we can decide the valency of an atom as well as of an element. This is the atomic structure. These are the orbits. And how many electrons are there in the different orbits. Via this, we can make the atomic structure of an element. Now valencies. What are valency? Valency is the combining capacity of an atom of an element. The electrons present in the outermost shell of an atom are called valence electron. If an atom's outermost shell is completely filled, they are known as inert as well as least reactive, and their combining capacity of valency is 0. Of the inert element, helium atom has 2 electrons in the outermost shell, and the atom of other elements have 8 electrons in their outermost orbit. Atoms having 8 electrons in their outermost orbit are known as octet configuration. Octet means 8, and this octet configuration is a stable configuration. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability by losing, gaining, or sharing electrons with other atoms, and to attain or achieve octet configuration. Number of electrons lost, gained, or shared by an atom to attain octet configuration is the combining capacity or valency of the element. For example, hydrogen, lithium, sodium, they can easily lose their 1 electron and become stable. So valencies are 1. In the case of magnesium, can easily lose 2 electrons, so its valency is 2. In the case of aluminum, 3, and in the case of carbon, 4. Fluorine can easily gain 1 electron and become stable, so the valency of fluorine is 1. Oxygen can gain 2 electrons, so the valency of oxygen is 2, and nitrogen can gain 3 electrons, so the valency of nitrogen is 3. Now atomic number and mass number. What is this atomic number? Atomic number of element is the number of protons present in the nucleus of the atom of an element. All the atom of element have a same atomic number. So suppose hydrogen atomic number 1, so number of protons are also 1. In the case of helium, atomic number 2, then number of protons are 2. In the case of lithium, atomic number 3, then number of protons are 3. We can represent this atomic number via Z. Mass number. The mass number of an element is the total of number of protons and number of neutrons. And these protons and neutrons are known as nucleons. Why? Because these protons and neutrons are present inside the nucleus of an atom. So the mass number of an element is the sum of the number of protons and neutrons present in the nucleus of an atom. The mass of an atom is mainly the mass of proton and neutron present in the nucleus. For example, carbon, mass number 12, then 6 protons and 6 neutrons. In the case of aluminum, mass number 27, then 13 protons and 14 neutrons. In the case of sulfur, 16 protons and 16 neutrons, then the mass number is 32 U. U means unit. Now, in the notation of an atom, the atomic number and mass number is written as like this. Suppose element is there, so upper side, whatever number value is there, that will represent the mass number of the element, and downside, whatever numbers value are there, that will represent the atomic number of an element. For example, see, suppose nitrogen, then 14 is the mass number, upper side 14 is the mass number, downside 7 is the atomic number of the nitrogen. Now isotopes. What are these isotopes? Isotopes are the atom of the same element having same atomic number but different mass number. For example, hydrogen has 3 isotopes like protium, deuterium and tritium. If we will see here, then these atomic numbers are same but mass numbers are different. This is the definition of isotope. Different mass number but same atomic number. Carbon has 2 isotopes like 12,6C and 14,6C. 6 atomic number, that is constant, same in both cases, and 12 and 14, these are the mass number, different mass number. In the case of chlorine has two isotopes like 3517Cl and 3717Cl. 35 and 37, these both are mass numbers, both are different, and 17 is the atomic number of the chlorine. Next, we will discuss about the isobars. What are the isobars? Isobars are the atoms of the different elements having different atomic number but same mass number. Different atomic number and same mass number. So these pairs of elements have a same number of nucleons like calcium. If we will see the calcium and argon, then mass numbers are same 40-40, but atomic number is different. Same in the case of iron and nickel, mass number is same, that is 58-58, but atomic number is different, that is in the case of iron 26 and the case of nickel 27. So dear children, this is the description of the chapter, that is structure of an